Hello everyone. In this video, we are going to discuss about some important terms which are related to cache memory. And these are very important terms which we should know before understanding the cache mapping techniques. So let's see what are those terms. So these are those terms which are related to your cache memory in your computer system. So it is cache hit, cache miss. Then we have the cache hit ratio, cache miss ratio, cache hit time, and cache miss penalty. So we will see that to understand these terms, what all relevant information we want. Okay. So first we will see that information before understanding these terms, and after that we will take one numerical to understand these terms. Okay. So before understanding those terms, we should know how main memory is organized. So main memory is organized in form of blocks. So what does it mean? So here you can see we have this main memory, okay, and these are written as block number 0, block number 2, and so on. Okay, so what does it mean? So here you can see inside main memory we have the words stored inside it. So word is word. Word is a unit of the data which can be transferred between the CPU and the main memory in one memory cycle, or let's say one CPU cycle in simple terms. Okay, so in your computer, let's say it can be like one word can be equal to of 2 bytes, 4 byte, or it can be equal to 1 byte also, depending on the architecture of the processor or architecture of a computer. Okay, so when we say that our main memory is organized in form of blocks, so what does it mean? So it means that all these words will be grouped in some unit, in big unit called as block. So it means, let's say word number 0 and word number 1, they are called that they are present inside memory block number 0. The same way word number 2 and word number 3, they are present inside block number 1. And word number 4 and 5, these are the block number 2. 6 and 7, these words are present inside block number 3, and this is the last block. So you can say block is a unit of the data which is consisting of some words inside it. Okay, so in this way we have divided the whole memory in form of blocks. So we understood that block can contain one or more words in it. Okay, so here we can see our block contains how many words? Each block contains 2 words. Block number 0 contains word number 0 and word number 1. Same way, block number 1 contains word 2 and word 3, and so on. So this is called block size. Block size means the number of words which are present inside a block. So in our case, for this example, your block size is equal to 2 words. Okay. So now let's see how cache memory is organized. So actually cache memory is also organized in form of blocks. So here you can see we have the cache memory, and inside cache memory we have some words stored inside it from word 0 to word 7. Okay, and here also we can say that block number 0 can contain 2 words, block number 1 is containing 2 words, and so on. Okay, so we have the 4 cache blocks. These are the cache blocks, and each cache block contain 2 words. So here also the block size is equal to 2 words. Okay, so now we have understood how the main memory is organized and how the cache memory is organized. Both are organized in form of blocks, and each block contain some words inside it. Okay, and one word can be of, let's say, any size. It can be 2 byte, 1 byte, 4 byte, and so on. Okay, so now let's understand how the data is transferred between CPU cache and main memory. Okay, so whenever CPU asks for some data from your cache memory, then your cache is searched if it contains data or not. If cache does not contain the data, then the main memory will be searched for that data which is asked by the CPU. Now main memory will contain data. We are assuming this. Okay, there are some cases in which main memory can also not contain the data which is getting accessed or which is requested by CPU. Those terms are called as page faults. Okay, but we are not considering any such type of things like page fault and so on. We are just understanding the basic concepts. Okay, so here we will assume main memory will always contain the data which we need. So CPU first searches the cache. Cache does not contain the data, so your main memory will be searched. Now main memory contains the data, so what will happen? So actually from main memory to cache, a single word will not come. Okay, actually blocks comes from main memory to cache, and from cache to CPU, the word from the block is transferred to the CPU. Okay, so what does it mean? So let's see this in more detail. So here you can see we have the CPU, we have this cache memory, and we have this main memory. Okay, so main memory is containing the words, and the words are organized in form of blocks. So again we will say that each block will contain two words. Here cache memory is also organized in form of blocks, and each block is of size two words. Okay, each block can contain two words. Now when CPU accesses the data or CPU demands for some data, so let's say CPU is asking for the data, let's say this word. Okay, CPU is asking for the word number 5. Okay, so CPU first searches this data to the closest memory. Okay, so what is the closest memory beside the CPU? So it is cache memory. So CPU first searches the data inside the cache memory. So there is no block which contain this word number 5 requested by the CPU. Cache memory say, okay, I have no data, so it asks the main memory to please get the data. Okay, so main memory says, okay, I have this data. So this word 5 is present in which block? This is present in memory block number 2. So only word number 5 is not fetched from this main memory to the cache. Actually this whole block number 2 will be coming to the cache memory. So word number 4 and word number 5 both will be coming to cache memory. And now where these word number 5 and word number 4 will be placed inside the cache memory? So it depends on the cache mapping technique. That is how this data of the memory will be mapped to the cache. At which location of the cache memory this main memory data will be placed. It depends on those cache mapping techniques. And those techniques we will be seeing into the next lectures and the next videos. So for the time being, let's say this block number 2 of the main memory is placed somewhere inside this cache memory. Okay, so let's say this block number 2 is placed in the cache block number 0. This is mapped to cache block number 0. So that means word number 4 and word number 5 of your main memory are placed inside cache block number 0. Okay, now what will happen? From cache memory to CPU, actually word transfer takes place. That means only this word, that is word number 5, which is desired by the CPU, which is requested by the CPU, it will be transferred. And here word number 5 will come to the CPU registers, and CPU can now use this word number 5. So that means here between the main memory and cache, block transfer takes place, and between the cache and the CPU, the word transfer takes place. So in this way, data transfer between the CPU, cache and main memory takes place. Now the next thing is, let's say CPU again demands for some new data. So for example, CPU demands for this word number 8, okay, which is present inside the block number 4 of the main memory. So word number 8 is requested. Okay, so first it will be checked inside this cache memory. There is no word number 8 inside this cache memory. So what will happen? Again a request will be going to the main memory, and inside main memory this word number 8 is present. So again word number 8 and word number 9 both will be coming to this cache memory. So that means total block number 4, this block of the main memory, will be coming to the cache. And where it will be placed, again it depends on the cache mapping technique. So let's say those techniques say that this block number 4 should be placed in the cache block number 2, and now your desired word number 8 will be going to the CPU, and CPU can use that word number 8. So in both of the cases, like when word number 5 was asked and word number 8 was asked, both were not present inside this cache memory. So we can say that we have missed or we have not found our desired word into the cache memory when we have asked the cache memory, or when CPU has asked the cache memory that please give me that particular word. So that is called cache miss. Okay, cache miss means whenever there is no word found which is requested by the CPU, then that scenario is called as cache miss. Okay, let's say the CPU asked for the some data which is already present inside your cache. So for example, CPU says, okay, I need word number 9. Okay, word number 9. And you can see that inside cache memory, CPU will ask, okay, please give me the word number 9. Can you see where is the word number 9? Inside this cache block number 2, we have the word number 9 present. That means your data is already present inside this cache memory. So you will not ask the main memory to give the word number 9 because it is already present inside cache memory. So this word number 9 will be going towards the CPU, and CPU can use this word number 9. So in this case, the data which is requested by the CPU is found inside your cache memory. So this scenario is called we have hit the cache. That is, the word has been found inside the cache which is requested by the CPU. So this is called cache hit. When we will not found the data inside the cache, it is called cache miss. And when we have found the data inside the cache, it is called cache hit. So now before proceeding forward, we should understand that word number 9 was actually fetched when we were fetching this word number 8 last time. You can see that when we have asked for the word number 8 last time from block number 4, then total block number 4 was coming. That is, word number 8 was coming, but word number 9 was coming in the second phase only when this word number 8 was asked. So that's why in the third case, when we asked for the word number 9, it was already present inside this cache memory. Okay, so if in case we have just fetched only word number 8 in the second case, then what will happen? Then in the third case, when we ask for the word number 9, then we have to again go to the main memory to find this word number 9, and this will take more time in comparison to the current time. Currently what happened, that CPU was finding this word number 9 already inside the cache. Okay, because it was coming into the second term with word number 8, but if was not present inside in cache memory, then we have to again go to the main memory. So you know that to access the data to the cache memory, it takes lesser time for the CPU. So you can say the access time to access the data inside the cache, it is nearly about 10 nanosecond. Like it is not the like hard and fast rule, like I am saying the general scenario. And in the same way, the time to access the data inside the main memory is nearly about, let's say, 20 nanosecond. Okay, so in third case only 10 nanosecond will be taken to access the this cache memory. Okay, and after that you will get the data. But if word number 9 is not present, then you will take like 20 nanosecond because you have to access the main memory, so it will be like more time. Okay, so now we are in this situation where we can understand the cache hit miss and cache hit ratio and so on, all those terms. So let's see. So first term is, what is cache hit? So as I described, cache hit means whenever our desired word, or you can say the block, is found inside your cache, then we will say that it is a cache hit. Okay, and who is asking for the word? It is asked by the CPU. Okay, so here you can see total 3 times requests were made to the cache memory to ask for the data. First it was asked for the word number 5, then CPU asked for the word number 8, then word number 9. So total how many times the cache was accessed? You can say total access to the cache was 3, right? Total cache access. Now if I ask you, out of 3 access, how many times your data or your word was present inside your cache memory, or it was found in the cache memory? So you will say only 1 time. Only word number 9 was found inside the cache memory. So there were only 1 hit inside this cache memory. Okay, and if I ask you how many misses were there, how many times we missed to found the data inside the cache memory, you will say 2 times, because word number 5 and word number 8 both were not present inside the cache memory. So cache miss will be 2. So we understood cache hit and miss. Cache miss means whenever our data is, or the word is, or the block is not found into the cache memory. Now here you can see, if we want to find the number of cache miss using the total number of cache hit, then we can find using this formula. This formula says the total number of access to the cache minus total number of cache hit. Then we can find the number of cache miss. So what does it mean? So here you can see total we have accessed the cache memory 3 times, and out of 3 only 1 time your data was found inside the cache memory. So that means how many times you missed to found the data inside the cache memory? You will say 2. This is like total 3 minus cache hit. Okay, so that is the formula. So that is like a aptitude question. Okay, now the next term is hit ratio. So what is hit ratio actually? So it means the frequency of the data that we have found inside the cache. Okay, so that means out of total cache memory access, how many times we have found the data inside the cache. So that is the hit ratio. That is the division of cache hit divided by total access is the hit ratio. So in this question, if I ask you what is the hit ratio, so you will say total 3 times cache was accessed, and out of 3 only 1 time your cache has given you the data, or data was found inside the cache. Okay, so this is the hit and this is the total access. So 1 upon 3 is the hit ratio. You can find in the like fraction also, it will be like 0.33. The same way, if I ask you what is the miss ratio, okay, so miss ratio is the opposite of the hit ratio. So it is like out of total access to the cache memory, so we have accessed the cache 3 times, okay, and how many times we did not find the data inside the cache memory? So you will say we missed 2 times. Okay, so that means 2 upon 3 will be the fraction or the miss ratio. Okay, so you can also find this miss ratio using the hit ratio also. Now if I ask you what can be the maximum and the minimum value of the hit ratio, so you will say it can happen that out of 3 times I can found all the 3 times data inside the cache. That means the hit ratio will be 1. It may happen that out of 3 times I will not find the data inside the cache any number of times. Okay, that means there is 0 cache hit. That means 0.3 will be 0. At that time hit ratio will be 0. So that means your hit ratio can vary between 0 to 1. So on the same line, if I ask you what is the miss ratio using the hit ratio, can you find out? So you can simply say miss ratio can be like 1 minus hit ratio. Okay, so it means 1 minus 1 by 3, 1 minus 1 by 3, it will be 2 by 3. So as you found the cache miss using the cache hit, the same way you can found the cache miss ratio using the cache hit ratio. So next two terms are cache hit time and miss penalty time. Okay, so both these terms we will be talking when we are discussing our numerical. So let's quickly move to our numerical and see how we can calculate all these terms. So here is our question. So let me explain this. So question says that CPU is requesting memory blocks 2, 3, 0 and 2. Okay, so CPU is there. It asks for the block number 2. After that, it asks for the block number 3, then 0, then 2. And these blocks are not the cache block. These are the main memory blocks. That is these blocks. Okay, and here we are given 3 times, and first line says that the time to access the cache is 10 nanosecond. That means CPU can access your cache in 10 nanosecond. The time to access main memory is 25 nanosecond. That means if CPU wants to access this cache, it will total take 25 nanosecond. And time to access main memory after the cache, that means if we are at cache and let's say we did not found any data in the cache memory which we are asking, then to talk to the main memory it takes 15 nanosecond. Okay, so this data is as such given to us. And the next thing we are given is inside this cache memory we have already two datas present, that is block number 3 and block number 0. That means this block and this block of the main memory, they are already present inside this cache memory. So at this instance, these 4 requests are made and we have to calculate all these given terms. Okay, so this is the question. So let's see. So first CPU asked for the memory block number 2. So CPU request for the memory block number 2. That means this block CPU is asking. So CPU first check inside this cache memory. Inside this cache memory only block 3 and block 0 is present. Block number 2 is not present. So we will check inside your main memory. So inside main memory we can see that we have this block number 2. So block number 2 will be fetched and it will be kept inside any of the empty blocks or empty space inside this cache, okay, using the mapping technique that we will see in the next videos. So let's say block number 2 is kept here. Okay, so here we see that block 2 was not found inside this cache, so it was cache miss. Okay, now when block number 3 was asked, so let's say block number 3 is asked. So block number 3 is first checked inside the cache memory. So block number 3 is already present. That means this is cache hit. Okay, now block number 0 is asked. So CPU asked for the block number 0. Again, block number 0 is already kept inside this cache memory. That means this is cache hit. We have found our block number 0 already in cache. Next, we asked for the block number 2. So CPU asked for the block number 2 again. Now, block number 2 is present inside this cache memory, which was fetched from the main memory when for the first time request was made. Okay, so this time for this fourth request, we have the cache hit because it is already present inside this cache memory. So out of 4 access, total 4 times we access the this cache, only 1 time we have missed our data inside this cache memory. 3 times we have hit the cache. So our total number of cache hit will be 3. Okay, and how many number of cache miss? That is only 1. That means block number 2 for the first time it was not found, so only 1 cache miss. Okay, next is cache hit ratio. So it means out of total number of access of the cache, how many times your data was found inside your cache memory. So out of 4 access, 3 times. Okay, only 3 times. That means this we found the data inside the cache. The next thing is cache miss ratio. So it means out of total access was made to the cache 4 times and we do not found the data only once inside the cache memory. So 1 by 4 will be the miss ratio. Now next thing is we can find this cache miss ratio using hit ratio also. How? So we know the maximum hit ratio can be 1 minus this 3 by 4. It will also give me 1 by 4. Okay, now next is cache hit time. So here you can see cache hit time means the time taken to access your requested data or requested word in your cache memory. Okay, when we ask for a particular data, okay, then what time it take to access that data into your cache memory, that time will be your cache hit time. So let's say we take one particular access, one particular request. For example, take the example of 3. Okay, so when CPU request for the block number 3, okay, and that is found actually inside this cache. Okay, so that means we have hit the cache. So in how much time we hit the cache? In 10 nanosecond, because this time is given to us. So this will be 10 nanosecond. So cache hit time will be 10 nanosecond. That means in 10 nanosecond we hit the cache to found our data. Next is miss penalty time. The time taken to process a cache miss. So what does it mean? So it means actually the extra time which is taken to load your cache with the data fetched from your main memory when cache miss occurs. So it actually means when you ask for some data and it is not present inside your cache memory, then what you do? You check your main memory and you fetch the data from main memory and you load it inside your cache memory. Okay, so miss penalty time means whenever you do not found your data inside your cache memory, then after that how much time it takes to load your data from main memory to cache. After your cache miss, what is the time taken to load your data into your cache memory? That will be your cache miss penalty time. We request, let's say for some block, which is not present inside your cache memory. So let's say this block number 2 is not present, okay, and block number 2 is asked, okay. So block number 2 is not found inside the cache memory. So what we did, we checked your main memory. So in how many times we are accessing this main memory? In 15 nanosecond, okay. Then in another 15 nanosecond, your data will be coming to your cache memory, okay, 15 nanosecond. So total how much time we took? Total 30 nanosecond we took to load your data from main memory to your cache memory, okay. So miss penalty time will be your 30 nanosecond. After your miss, how much extra time was taken, okay, you will not add this 10 nanosecond, okay. After 10 nanosecond, what is the extra time taken? That is miss penalty time. I hope now you have understood the various terms and their meaning and how we can calculate. Do like and share this video and subscribe this channel and press the bell icon for further notification. In the next video, we will see the cache mapping technique. So see you in the next video. Till then, goodbye.